Hello students and welcome to the 57th lecture on particle physics. And on the last turn, we had started the discussion on laboratory frame and center of mass frame of references. And I had told you that one can perform experiment in lab frame and report to a person who is performing the experiment in center of mass frame, and then we can have a discussion on the results. Remember, when we were talking about the discovery of J by psi meson, then this J by psi meson, this particle was discovered at Brookhaven National Laboratory as well as Stanford Linear Accelerator Center. At Brookhaven, there was laboratory experiment, and at SLAC, it was the center of mass experiment. But the spike in the event rate came around 3.1 GeV, and from there it was inferred that both the people are observing a new meson, and that was called as J by psi meson. Therefore, the important catch is that if I have got a particular center of mass energy, and whether the experiment is being performed in lab frame or center of mass frame, we have to be careful about what we are talking about. Okay, and then today we are going to first talk about the center of mass system, as the laboratory system we have discussed in detail on the last turn. Therefore, in the center of mass system, what I am talking about, that if say A plus B is giving rise to 1 plus 2. Therefore, what is happening? These two guys, A and B, these two guys are coming, collision is taking place, and you have 1 and 2 in the final state. Okay, therefore, this set of mass frame is different from laboratory frame. In laboratory frame, one fellow was at rest and another guy was coming with certain energy and momentum. Here, both the fellows are coming with certain energy and the same magnitude of the momentum. Okay, and that means what I am telling you, that let us denote this by PA star for the center of mass plus PB star. This is 0. Or P1 star, because from the momentum conservation, this is equal to 0. This asterisk simply is telling you that we are working in the center of mass frame. Otherwise, if you prefer, all the time you can write CM to not get confused about what we are talking about. Now, when we are saying S, now by definition, this S is PA plus PB whole square, and when S is PA plus PB whole square, then that means this is EA star plus EB star whole square minus PA star plus PB star whole square, and this is the second part is 0, and therefore what is your square root S? This is EA star plus EB star. This is what I call as center of mass energy. And now this square root S, if you wish, we can write it as PA star square plus MA square plus PB star square plus MB square. And the important point is the magnitude of PA is the same as the magnitude of PB. This is the condition of the center of mass frame. Therefore, your square root S is simply P star square plus MA square plus P star square plus MB square. This is the general cast that one can talk about, and that means I can write this square root S minus this guy, this is equal to this fellow. And then in my next step, I can square both these sides, and then This will be S minus 2 square root S times EA star. This will be P star square plus MB square. Therefore, just let me write down this again. This we are writing, we are squaring this. Therefore, this is S minus 2 square root S times EA star plus P star square plus MA square. This is on the right hand side, P star square plus MB square. And notice that P star square cancels out, and what you have EA star. This is equal to S plus MA square minus MB square by twice square root S. Notice EA star is S plus MA square minus MB square upon twice square root S. Therefore, notice that when we were doing the case where in the lab frame this was S was M1 square plus M2 square plus twice M2 E lab, and I had told you that if I know the laboratory energy, equivalent center of mass energy, I can tell you, and then we can see that what should be the energy of the particle A and what should be the energy of the particle B in the center of mass frame. Therefore, notice that I am providing 500 MeV of energy to the electron in lab frame. That means I am here. I know S, that means, and if I know S, I know square root S, and the particles which we are talking about, they are the same particles. If this A and B are the same as 1 and 2, then that means I know MA and MB, I know S and square root S. That means I know the energy, center of mass energy of the particle A. And not only that, if you notice it carefully, instead of putting this to the left hand side, we could have put this guy to the left hand side and this fellow to the right hand side. Then what will happen? Then you will have EB star as equal to S plus MB square minus MA square by twice square root S. Therefore, you know EA star, you know EB star. Now, once you know EA star and EB star, then what is the next point? The next point is P star, and P star will be magnitude wise, it will be the same. Therefore, P star magnitude wise, this will be either you write EA star square minus MA square, or you can write it as EB star square minus MB square. And you notice that these two in the center of mass frame will be exactly the same in magnitude. You know only E lab, you have evaluated the equal center of mass energy. From there you have evaluated that how much energy I should give to A and to B to collide, to have the same scenario. And then from here, that means you also know that what should be the momentum of the particle A and the momentum of the particle B. They should be same in magnitude. That means you also know the kinetic energy of the particle A and particle B in the center of mass frame. This is the beauty of the quantities that we talk about in lab frame, in center of mass frame. Therefore, we know EA star, we know EB star, and from there we can evaluate all these quantities. And not only that, you can also see that if you can do it as a homework. Instead of S, you can write it in some other way. only in terms of momentum. Like if I write, say my EA star is S plus MA square minus MB square by twice square root S. Look at it carefully. My EA star is S plus MA square minus MB square upon twice square root S. Then what we can do, we can square both the sides and we can write 4S EA star square. This is equal to S plus MA square minus MB square whole square, and then this 4S I can write it as P center of mass square plus MA square. This will be S plus MA square minus MB square whole square. That means my P star square plus MA square, this is this quantity, over 4S. That means my P star will be square root of S plus MA square minus MB square whole square upon 4S minus MA square. You can also, in some of the cases, instead of people talking about this, you can also find that people write, but as you can see that just it is energy and momentum, there is nothing more to it. But the important catch is you have both the things, the equivalent lab energy or equivalent center of mass energy. Now similar to that, if you consider T is P1 minus P3 whole square. Therefore here it will be E1 minus E3 whole square minus P1 minus P3 whole square. Therefore, the other important point is, before I proceed ahead, and this perhaps we had discussed while talking about proton-proton scattering that is going on at CERN, where they are colliding two protons beam in the opposite direction. What I had told you, that each proton has got approximately, say, to make life simple, 5 trillion electron volt. Trillion electron volt is 5000 giga electron volt. And you see, we are talking about proton of this much energy. Then you know that the rest mass energy of the proton is only 0.938 GeV. Therefore, whatever energy that we are talking about, in principle, that is nothing but the kinetic energy of the proton. Okay. Now what I am telling you, that each proton is coming with 5 TeV of energy. That means in the center of mass frame, what is happening? This square root S is E1 star, or let us see, both of them are proton, EP star plus EP star. And this is nothing but 10 trillion electron volts. Therefore, if I am saying that I am performing an experiment in laboratory frame where the total energy available to me, center of mass energy available to me, is 10 trillion electron volt. So this is nothing but the total center of mass energy available to us. Now, if I want to do the same experiment in laboratory frame, then the important point is, if I want to do the same experiment in the laboratory frame, then in laboratory frame, one guy has to be at rest and another fellow has to come only with certain kinetic energy. What should be that kinetic energy? Therefore, recall again, S in laboratory frame, this will be PP square plus PP square plus twice pp dot pp, because both of them are the protons, and then this is mass of the proton square plus mass of the proton square plus one guy is at rest, since therefore whatever energy I have to give them to the projectile, and that is what I am writing it as E lab. Now you see that square root s is 10 TeV, therefore here s is 100 TeV square, and then 100 TeV square, if you square this, 0.9, this is nothing but 0.9 into 10 power minus 3 TeV. You can directly say that this is 10 power minus 6, this is 10 power minus 6, forget it. Therefore, this is 2 into 0.9 into 10 power minus 3 into EP lab. And therefore, EP lab is 100 by 2 into 0.9 into 10 power minus 3. And that means just remove this, put here 1000, then and then 10 power minus 3, another 3. This is 18. That means, let us say this is 9. This will be 5, 0, 0, 0, 0, 0 upon 9. Let's just approximate it to 10. That means 1 0 I will remove. This will be this much TeV. That means 50,000 TeV. I have to provide it to the projectile to have the same set of mass energy. And that is why to perform this experiment in the laboratory frame is not possible in the next 1000 years. Because we have achieved energy up to 7 TeV at LSC for the one proton and for the another proton. To get 50,000 trillion electron volt, unless we come out with out of box idea to accelerate particle to this much amount of energy. Now to get this for 14 TeV or 12 TeV, we need at circumference of 27 kilometers at LSC. Now you can imagine, and this we will talk about when the future colliders, what will be the circumference of those colliders in comparison to the what we have at LSC, and you will see that really to get huge amount of energy, it is not really easy to achieve. And the important point is that we have center of mass experiment, we have laboratory experiment. The question arises, which one should prefer? And the answer to that is both of them are important. Because if you want to study new particles, exotic particles, then you go for colliding beam experiments. Because, for example, at LSC, when people were looking for Higgs boson or supersymmetric particles, which they have not observed, but Higgs they have observed, they want to create, see the quark-gluon signals that we have talked about when the universe was microsecond old. Therefore, people are mimicking that situation and trying to understand the physics that would have existed at the time of Big Bang when the universe was microsecond old. Therefore, in these circumstances, when you want to study or see the new particles and exotic particles, etc., then you need colliding beam experiments, because here you can accelerate both the particles and then they collide. But if you want to study a specific reaction, I want to study pion-proton scattering, for example. I want to study electron-proton scattering, for example. I am interested in the study of electron-proton going to electron plus neutron plus pi plus, and my detector is sensitive to detect pi plus. Now in laboratory experiment, what happens? and that we will see, most of the events they come in the forward direction. While in center of mass experiments, it is something like you are colliding two clays, and then where the particle will go, you don't know. Therefore, you want to cover it by a 4-pi detector. While in the laboratory experiment, what we do, we put detectors at the front side, and most of the events we get at the at small scattering angles. That means this is the beam. We are putting detectors here at small scattering angles. Now, most of the events will come at this point. Only a few we will get at this point. And therefore, the detector cost is less here. While in the case of colliding beam experiments, you might have heard that LSC is using several detectors, Atlas, CMS, and to build Atlas, there are more than 1500 people who are collaborating in that project. To build a CMS detector, there are again more than 1500 people. Similarly, to see the quark-gluon plasma signals, again there are thousands of people who are working on, who have worked to build that LS detector, and similarly you have many other detectors. Therefore, in this case, when you are doing a high energy scattering experiments, when you are colliding the particles, then it is something like you have a lawn tennis ball and that you want to cover it by a football, and therefore all the particle which will come out from here will strike somewhere on the surface of the football. And the important point is these Higgs particulate etc. Since to get significant number of events, we had Atlas detector as well as CMS detector to really reach onto the conclusion that really we have found out Higgs. Okay. Therefore, the important point is that both the experiments are important, are essential to us to understand the particular property, to understand a particular scattering results. We need laboratory experiments, and to see new particles, exotic particles, etc., to mimic Big Bang, etc., there we need colliding beam experiments. Therefore, but the important point is we can go from lab frame to center of mass frame or center of mass frame to lab frame. Now today what we have done, we have discussed about the equivalent energy, and then what is our next target, to relate theta lab with center of mass scattering angle. Say this is the center of mass angle, and that means I know energy of the incident particle and theta lab. Then we have evaluated that what will be the equivalent center of mass energy. Then we will also see that what should be the equivalent phi to place that detector at a particular angle phi. But all this becomes very simple if we understand Lorentz transformation. As you know that we have two inertial frame of references where the law of inertia is valid, say S and S prime, and say S prime is moving with a velocity v, and some event takes place at say point E. In S, the coordinates are time t when it has happened, the position coordinate x, y, and z. In S prime, time is t prime, x prime, y prime, and z prime. These are all relativistic particles which we have discussed, whether we talk about neutrino, electron, or whatever it is. Therefore, and we also know that whatever result that we get in relativity, they are also valid in non-relativistic limit. Okay. Therefore, it is not that if we are talking about relativity, then non-relativistic results are completely different. They are the same, and we will see that if the mass of the particle is larger than the momentum of the projectile or the scattering that we are talking about, then in that limit the kinetic energy is nothing but half mv square. Therefore, what is important, that we have two frame of references, s and s prime, and if we are, and s prime is moving with a velocity v, and if we are want to observe an event, then this coordinates x, y, z, t are related to x prime, y prime, z prime and t prime through a Lorentz transformation, where x prime is gamma x minus vt, y prime is y, z prime is z, and t prime is gamma t minus vx, well known results of special theory of relativity. Or if we want to see from s prime to s, just what we have to do, we have to change v by minus v, and therefore this will become, x will be equal to gamma x prime plus vt prime and all that. And what is this gamma? This is known by the name Lorentz factor. This is 1 over square root 1 minus v square by c square. Or in natural units, when we consider c to be equal to 1, this is simply equal to 1 over 1 minus v square. Therefore, in the system S and the system S prime, we have these relationship. If the frame is moving along the x direction, we have the relation between x prime t. This should be t prime, and similarly t is t prime. Therefore, this is nothing but t prime. Make a correction. While x prime is x minus vt upon square root 1 minus v square c square, and t prime is t minus vx by c square root 1 minus v squared by c square. Now, these transformations are also related through a matrix that we know very well, that we can write it in the matrix form. This is t prime, x prime, y prime, z prime, and this is related to x, y, z, t. This is gamma minus gamma v. Gamma is square 1 over square root 1 minus v square by c square, and therefore when we are writing, this is the x component, this is the t component, here we have minus gamma v, and that is what we are writing here, gamma minus gamma v 0 0. This is the time component, this is x component, y component and z component. And then we also write the length element square as c square dt square minus dx square minus dy square minus dz square, and this is equivalent to the quantities in S prime frame, the well-known result of relativity. And then we know that we have a transformation from frame S prime to frame S regarding all this, and this transformation mu nu is known by the name Lorentz transformation. Now, similarly, we have the velocity transformation, and in velocity transformation what we have, this ux prime is dx prime by dt prime, and since x prime is gamma x minus vt, therefore dx prime is gamma dx minus v dt, t prime is gamma t minus vx by c square, and therefore dt prime is gamma dt minus v dx by c square. This is what I have done. And then gamma, these two Lorentz factors will cancel out, and if I divide in both the numerator and denominator by dt, then we get a result ux minus v upon 1 minus v ux by c square. This is the velocity in x prime, where the frame s prime itself is moving with a velocity v, and we are observing an event, and the event is moving with some velocity u as measured in the frame S. Then the frame S prime is measuring its velocity to be u prime, and this is what we are writing it as. The x component ux prime is ux minus v upon 1 minus v ux by c square. Again, if you want to relate the x component to the prime components, then you have to replace just v by minus v, and this will give you ux is equal to ux prime plus v upon 1 plus v ux prime by c square. Therefore, these are the important results which we have to understand, and I will start from this place tomorrow, and then we will see that how energy and momentum transforms, and how then finally the angle transformation takes place. Let's stop here. Thank you very much.